Welcome to Study Loop.
So in this problem, we are given a three buffer solution of three different pH values, and we have to calculate the molar solubility of calcium hydroxide in these buffer solutions. So to do that, what we have to do first is to find out the hydroxide ion concentration from the pH value, and then we will have to set up the dissolution reaction for calcium hydroxide, and from there we'll have to set up an ice table to find out the relation between the KSP and the molar solubility of calcium hydroxide, and from there we'll be able to find out the molar solubility of calcium hydroxide in each solution. So in first what we have to do is to find out the hydroxide ion concentration from the pH. So for this one, the pH value was 4. That means that as we know that pH means the negative log of H plus concentration is 4. That means H plus concentration is 10 to the power minus 4. And then we know that the relation between H plus and OH minus is KW is equal to H plus times OH minus, or OH minus is equal to KW over H plus, and we have KW value of 1 times 10 to the power minus 14, and H plus value is 1 times 10 to the power minus 4 from here. So from here we will find the hydroxide ion concentration is 1 times 10 to the power minus 10. Now we have to set up the dissolution reaction for calcium hydroxide. So calcium hydroxide, we'll have to write it as a solid, and we'll have to set up the equilibrium with its ions. So we have 2 hydroxide ion here, so we'll have to put a 2 here. And then if we set up the ice table for this, so initially we will not have any calcium ion present, but as the pH is 4, and from pH 4 we have seen that for a solution of pH 4 the hydroxide ion concentration is 1 times 10 to the power minus 10. And then if the change in the concentration is the change in the concentration of calcium ion is the molar solubility of the calcium hydroxide, and if we consider there is no change in hydroxide ion concentration, then in the equilibrium we will have the calcium ion concentration as molar solubility S, and the hydroxide ion concentration as before, 1 times 10 to the power minus 10. Now as we know that the KSP value for a compound is basically the product of its ion. So KSP value for calcium hydroxide will be concentration of Ca2 plus times OH minus, and since there are 2 OH minus, we have to put the 2 as a square here. And the KSP value for calcium hydroxide, we can find it from the table, which is 4.68 times 10 to the power minus 6. And the calcium ion concentration in the equilibrium was the molar solubility S, and times we have 1 times 10 to the power minus 10 whole square. So now if we just solve this equation for S, we will find the value of S, or the molar solubility, for this case as 5 times 10 to the power 14 molar. So this is the molar solubility of calcium hydroxide in a buffer solution with pH 4. Then we can do the or solve the other two parts just using the same process. So for the second one, we have a pH of 7. So if we just go back here and we just put 7 here, then our similarly we'll have a 7 here, and finally the OH or the hydroxide ion concentration will be 10 to the power minus 7, and then here we will have 10 to the power minus 7, and finally here we will have 1 times 10 to the power minus 7 as the hydroxide ion concentration. So this is the hydroxide ion concentration for pH 7, and then if we again go to here in the dissolution reaction for calcium hydroxide, similarly these values will remain same for pH 7 also. We just need to change the hydroxide ion concentration 1 times 10 to the power minus 7, and then finally in the KSP equation we will have all values same. Instead of just the hydroxide ion concentration, we can just change it to 10 to the power minus 7, and then uh, for this we will have the value of S as, if we just solve this equation, we'll have an S value for 5 times 10 to the power minus 8, 5 times 10 to the power 8 molar. So this is the S value for pH 7, and this is for pH 4. And then finally we have to calculate it for pH 9 the same way. We just have to replace the pH value here as 9, and then we'll have the hydrogen ion concentration is 10 to the power minus 9, and we just replace the values of 7 with 9, and then in the equation again these values will not change. We'll just have to change the hydroxide ion concentrations minus 9 minus 9. Now in this expression again we just have to change the value for the hydroxide ion concentration there. Okay, so here we will have 10 to the power minus 5, not 9, and then here we will have also 10 to the power minus 5, and then finally here we will have 10 to the power minus 5, and from here if we just solve this equation we will have the S value as 5 times 10 to the power 4 molar. So this is the molar solubility of calcium hydroxide in a buffer solution with pH 9. So this is the molar solubility of calcium hydroxide in a buffer of pH 4, 5 times 10 to the power 14, then 5 times 10 to the power 8 is for pH 7 buffer solution, and 5 times 10 to the power 4 is for pH 9 buffer solution.